Imagine a world where we harness the power of electricity, not just through wires and cables, but through the very air around us. Imagine an inventor whose genius not only lit up our cities, but also envisioned a future where energy flowed freely and wireless. This is the legacy of Nikola Tesla, a man whose innovations have shaped the modern world in ways most of us can scarcely imagine. Nikola Tesla, born in 1856, was not just an inventor, but a visionary whose work laid the foundation for many of the technological advancements we enjoy today. His contributions to the development of alternating current AC motors revolutionized the way electricity was distributed and used, effectively ending the war of currents and illuminating the world. But Tesla's genius didn't stop there. His relentless pursuit of innovation led him to explore the possibilities of wireless technology, aiming to transmit energy without wires, a concept that was far ahead of his time. Today, we see the echoes of his pioneering work in wireless charging, radio, and even the internet. Join us as we delve into the extraordinary life of Nikola Tesla, exploring his groundbreaking work with AC motors and his visionary dreams of wireless wonders. Discover how one man's brilliance continues to electrify and inspire our world. Section 1. Early Life and Education. Nikola Tesla was born on July 10, 1856, in the small village of Smiljan, located in what is now Croatia. At the time, this region was part of the Austro-Hungarian Empire. Tesla was one of 5 children in his family and showed early signs of his remarkable intelligence and creativity. Tesla's family background played a crucial role in shaping his future. His father, Milutin Tesla, was an Orthodox priest and a writer. Milutin was a well-read man, fluent in several languages, and known for his eloquent sermons and philosophical writings. He instilled in Nikola a deep respect for learning and discipline, often encouraging him to read and memorize classic works of literature and philosophy. This intellectual environment fostered Tesla's innate curiosity and love for knowledge. Equally influential was Tesla's mother, Georgina Duca Tesla. Despite having no formal education, Georgina was incredibly inventive and practical. She possessed a remarkable talent for crafting and inventing small household appliances to simplify daily chores such as mechanical egg beaters and looms. Tesla often credited his mother's inventive prowess and practical skills as significant influences on his own creative inclinations. Her ingenuity and hands-on approach to solving everyday problems left a lasting impression on young Nikola. Growing up in the picturesque countryside of Smiljan, Tesla was surrounded by the natural beauty of the area, which also sparked his imagination and curiosity about the world around him. As a child, he was fascinated by the forces of nature and often engaged in experiments to understand them better. One notable story from his childhood involves a young Tesla attempting to harness the power of the wind to create a perpetual motion machine. While the machine didn't work, it exemplified his early fascination with harnessing natural forces, a theme that would dominate his later work. Tesla's formal education began at the Realschule in Karlstadt, where he demonstrated a remarkable aptitude for mathematics and physics. His teachers were amazed by his ability to perform complex calculations in his head, a skill that hinted at his extraordinary mental capabilities. After completing his education at Karlstadt, he attended the Polytechnic Institute in Graz, Austria. Here, Tesla's intellectual abilities truly began to shine. He immersed himself in the study of electrical engineering, attending lectures with such intensity that he often worked through the night. During his time at the Polytechnic Institute, Tesla encountered the concept of alternating current, AC, for the first time. This idea would later become the cornerstone of his most significant contributions to electrical engineering. However, his educational journey wasn't without its challenges. Despite his academic brilliance, Tesla struggled with the rigid structure and traditional teaching methods of the time, often clashing with his professors over unconventional ideas. Tesla's thirst for knowledge eventually led him to the University of Prague, where he continued his studies in mathematics and physics. Although he faced financial difficulties and the loss of his father during this period, Tesla's determination never wavered. His relentless pursuit of education and innovation during these formative years laid the groundwork for the revolutionary inventions that would soon follow. Anecdotes from his youth often foreshadowed his later achievements. For instance, he once imagined a device to harness the power of Niagara Falls, a dream he would later realize as part of his work on hydroelectric power. These early signs of genius, combined with his photographic memory, set Tesla on a path to becoming one of the most influential inventors in history. Section 2. The AC motor and the war of currents. In the late 19th century, the world was undergoing rapid industrialization, and the need for efficient electrical power systems was becoming increasingly critical. This period saw the rise of the war of currents, a fierce battle over the future of electricity distribution. The conflict primarily revolved around two competing technologies: direct current, DC, and alternating current, AC. Thomas Edison, a prolific inventor and entrepreneur, championed the use of direct current, DC. Edison's DC system was straightforward and effective for short-distance electrical transmission. It worked well for localized electrical grids, providing power to homes and businesses within a limited area. However, DC had significant drawbacks when it came to long-distance transmission. The inherent nature of DC caused substantial energy losses over long distances, making it inefficient for widespread electrical distribution. On the other hand, Nikola Tesla introduced the concept of alternating current, AC. AC had several distinct advantages over DC. The primary benefit of AC was its ability to be transformed to higher or lower voltages using transformers, allowing it to be transmitted over long distances with minimal power loss. This made AC the ideal choice for a burgeoning industrial world that needed a reliable and efficient way to deliver electricity across vast areas. Tesla's work caught the attention of George Westinghouse, a successful industrialist and inventor. Westinghouse recognized the potential of Tesla's AC system and saw it as the future of electrical power. The collaboration between Tesla and Westinghouse began in the late 1880s when Westinghouse learned about Tesla's work on AC motors and transformers. Impressed by Tesla's innovations, Westinghouse invited him to Pittsburgh to work together on developing AC power systems. With Westinghouse's financial backing and industrial resources, Tesla was able to refine and expand his AC technology. Westinghouse's support for Tesla's AC system was crucial in advancing the technology and promoting it as a viable alternative to Edison's DC. Together, they worked on perfecting the AC motor, a device that would become a cornerstone of modern electrical engineering. The development of the AC motor was a significant milestone. Tesla's AC motor operated on the principle of rotating magnetic fields, which he had conceptualized and brought to fruition through rigorous experimentation. Unlike DC motors, which used brushes and commutators to transfer electricity, Tesla's AC motor was brushless and much more efficient. It utilized a rotating magnetic field to induce current in a secondary coil, creating a continuous motion. This innovation not only improved efficiency, but also reduced wear and tear, making the motors more durable and reliable. The introduction of the AC motor revolutionized electricity transmission. It enabled the efficient and cost-effective distribution of electrical power over long distances, which was not possible with DC systems. The success of AC power systems was demonstrated on a grand scale during the 1893 World's Columbian Exposition in Chicago, where Westinghouse, using Tesla's AC system, illuminated the fairgrounds with an unprecedented display of electric lights. This event showcased the superiority of AC power and marked a turning point in the war of currents. The impact of AC on modern electrical systems and the power grid was profound. Cities and industries across the United States and around the world began adopting AC power for their electrical needs. Major urban centers like New York, London, and Paris saw their streets and buildings lit up with the new, efficient AC electricity. Industries benefited from the reliable and scalable power supply, which fueled further technological and economic growth. The long-term implications of the victory of AC were immense. Tesla's vision of an interconnected world powered by efficient and widespread electricity became a reality. The principles of AC power transmission that Tesla developed continue to underpin modern electrical grids, enabling the global distribution of electricity that supports our contemporary way of life. His collaboration with Westinghouse not only ended the war of currents, but also set the stage for the electrified world we live in today. Section 3. Tesla's innovations in electrical engineering. Nikola Tesla's contributions to electrical engineering were vast and transformative. Over his lifetime, he was awarded more than 300 patents for his inventions, many of which laid the groundwork for the modern technological landscape. Let's explore some of Tesla's most notable inventions and their enduring impact. Tesla's key inventions include the Tesla coil, the induction motor, and his work on wireless communication. Each of these innovations had a specific purpose and application, pushing the boundaries of what was technically possible in his time. The Tesla coil, perhaps Tesla's most famous invention, was developed in 1891. This device is capable of producing high-voltage, low-current, high-frequency, alternating current electricity. The Tesla coil operates by creating a resonant transformer circuit. It consists of two parts, a primary coil and a secondary coil. The primary coil receives a burst of high-voltage current, creating a magnetic field. This magnetic field induces a current in the secondary coil, resulting in extremely high voltages. The Tesla coil's ability to generate electrical arcs and sparks makes it a fascinating and visually impressive device. The Tesla coil has numerous applications, especially in the field of radio technology. It was initially used to demonstrate the principles of wireless energy transmission. Tesla envisioned it as a means to transmit electrical power without wires, a concept that was revolutionary at the time. Beyond its intended purpose, the Tesla coil became instrumental in the development of early radio technology. It was used in radio transmitters to generate the high-frequency alternating currents necessary for transmitting signals over long distances. This innovation paved the way for modern radio communications and broadcasting. In addition to the Tesla coil, Tesla made significant contributions to radio technology. He experimented extensively with wireless communication, aiming to transmit information without the need for physical connections. Tesla's work in this area often brought him into conflict with contemporaneous inventors like Guglielmo Marconi. While Marconi is often credited with the invention of the radio, Tesla's patents and experiments were crucial in the development of the technology. Tesla demonstrated the transmission of radio waves as early as 1893, and many of his innovations were later utilized by other inventors to advance radio communication. Tesla's experiments with high-frequency and high-voltage electricity were groundbreaking. He conducted numerous experiments to explore the properties of these types of electricity, often with astonishing results. For example, Tesla's work with high-frequency currents led to the development of the Tesla coil and other high-voltage devices. One key experiment involved passing high-frequency currents through his body to light a bulb without wires, showcasing the potential of wireless energy transmission. The outcomes of these experiments had far-reaching implications for later scientific developments. Tesla's pioneering work in the field of alternating current and high-frequency electricity influenced many areas of science and technology. His experiments laid the groundwork for the development of various electrical devices and systems, including radio, television, and even early computing technologies. Tesla's influence on modern technologies cannot be overstated. Many current technologies trace their origins back to Tesla's work. For instance, the principles of wireless communication he explored are fundamental to modern wireless technologies such as Wi-Fi and Bluetooth. Additionally, the concept of wireless power transmission, which Tesla envisioned with his Wardenclyffe Tower project, is now being realized in technologies like wireless charging for smartphones and electric vehicles. Modern scientists and engineers frequently acknowledge Tesla's influence on their work. For example, physicist and futurist Michio Kaku has often spoken about Tesla's visionary ideas and their impact on contemporary science. Kaku has noted Nikola Tesla was a man out of time. He envisioned a world where wireless energy could power the globe, a concept that is just now being realized with modern technology. Tesla's innovations in electrical engineering were not just groundbreaking in their time, but have continued to influence and shape modern technology. His inventions and experiments laid the foundation for many of the conveniences and advancements we enjoy today. Tesla's legacy as a pioneer in electrical engineering remains firmly established, and his visionary ideas continue to inspire new generations of scientists and engineers. Section 4. Wireless power transmission. One of Nikola Tesla's most ambitious and visionary projects was the concept of wireless power transmission. Tesla believed that it was possible to transmit electricity without wires, providing free and ubiquitous energy across the globe. His vision was to create a system that could deliver power wirelessly to homes, industries, and even transportation systems, revolutionizing how energy was used and distributed. Tesla's ideas for wireless power were rooted in his understanding of electromagnetism and resonant frequency. He proposed that the Earth itself could be used as a conductor, with energy transmitted through the ground and the atmosphere. Tesla envisioned a network of towers that would send and receive electrical energy wirelessly, eliminating the need for traditional power lines and infrastructure. The most significant embodiment of Tesla's wireless power vision was the Wardenclyffe Tower project. Located in Shoreham, New York, the Wardenclyffe Tower was constructed in the early 1900s with the backing of financier J.P. Morgan. The tower, standing 187 feet tall, was designed to be a prototype for Tesla's global wireless power transmission network. Tesla planned to use the tower to demonstrate the feasibility of transmitting electrical energy and communication signals over long distances without wires. Tesla conducted numerous experiments and demonstrations at Wardenclyffe. He was able to light bulbs wirelessly from several miles away and even envisioned the possibility of powering ships at sea and aircraft in flight. However, despite the promising experiments, Tesla faced significant challenges. The project encountered severe financial difficulties, largely due to the high costs of construction and operation. Additionally, J.P. Morgan and other investors grew skeptical of the project's viability and potential profitability, leading to a lack of continued financial support. The scientific community of the time was also skeptical of Tesla's wireless power ideas. Many scientists and engineers doubted the practicality of his concepts, particularly the efficiency and safety of transmitting high-power electricity through the atmosphere. This skepticism, combined with the financial troubles, ultimately led to the abandonment of the Wardenclyffe project. The tower was dismantled in 1917, marking a significant setback in Tesla's quest for wireless power. Despite these challenges and setbacks, Tesla's experiments in wireless power transmission left a lasting legacy. His pioneering work laid the theoretical and experimental groundwork for modern wireless technologies. Today, we see many applications of wireless power that trace their origins back to Tesla's visionary ideas. Wireless charging of electronic devices, such as smartphones and electric vehicles, relies on principles of inductive coupling and resonant frequency that Tesla explored in his experiments. Furthermore, Tesla's dream of long-distance wireless energy transmission continues to inspire contemporary research. Scientists and engineers are developing new methods to transmit power wirelessly over greater distances, with potential applications in space-based solar power and wireless energy grids. Companies like Witricity are working on technologies to wirelessly transmit power to a variety of devices, pushing the boundaries of what Tesla first envisioned. In many ways, Tesla's ideas paved the way for the modern wireless technologies we use today. His work demonstrated the possibilities of transmitting energy without wires and sparked a century of innovation and exploration in this field. As wireless power technology continues to advance, Tesla's legacy as a pioneer and visionary in electrical engineering remains more relevant than ever. His relentless pursuit of innovation, even in the face of skepticism and financial challenges, continues to inspire new generations of scientists and engineers to push the boundaries of what is possible. Section 5. Later Life and Legacy. After his groundbreaking work with AC motors and wireless power transmission, Nikola Tesla's later life was marked by a mix of continued innovation, personal struggles, and fluctuating public perception. Despite his many contributions to electrical engineering, Tesla faced significant financial difficulties and periods of obscurity. In his later years, Tesla continued to work on a variety of projects and ideas. These included the development of a particle beam weapon, which he called the Teleforce or Death Ray. He also explored the possibilities of wireless lighting and advanced turbine designs. However, many of these projects remained theoretical or were never fully realized due to a lack of funding and support. Tesla's personal and financial struggles were pronounced. He spent the last decades of his life living in a series of New York hotels, often moving due to his inability to pay the bills. Despite his financial woes, Tesla maintained his dignified demeanor and continued to speak about his visions for the future. He was a familiar figure in New York, known for his eccentric habits and sharp intellect. Public perception of Tesla during his lifetime was mixed. While he was celebrated for his early contributions to electrical engineering, his later years saw a decline in recognition. He was viewed by some as a forgotten genius, overshadowed by contemporaries like Thomas Edison and Guglielmo Marconi. Tesla made notable public appearances and gave interviews, during which he spoke about his past achievements and future ideas. These appearances helped keep his name in the public eye, albeit in a diminished capacity. After Tesla's death on January 7, 1943, the perception of his contributions began to shift significantly. Posthumously, Tesla was recognized as one of the foremost pioneers in electrical engineering. His inventions and theories were re-evaluated, and his impact on modern technology became more widely acknowledged. Numerous awards and honors have been bestowed in his name, including the Nikola Tesla Award, which recognizes outstanding contributions to the generation and utilization of electric power. Tesla's influence on contemporary technologies and innovators is profound. Many modern inventors and engineers draw inspiration from his work. For example, Elon Musk named his electric vehicle company Tesla in honor of the inventor, emphasizing the impact of Tesla's work on sustainable energy and innovation. Tesla's ideas about wireless communication and energy transmission continue to inspire cutting-edge research and development in fields such as wireless charging and renewable energy. The cultural impact of Tesla's legacy is also significant. He has become a symbol of unbridled creativity and scientific genius. Tesla's life and work have been the subject of numerous books, films, and documentaries. His story resonates with many as a tale of brilliance, perseverance, and the quest for knowledge. In the modern era, Tesla's legacy has been re-evaluated and celebrated. Recent discoveries and inventions highlight the foresight of his ideas. Innovations in wireless technology, renewable energy, and even space exploration can trace their conceptual roots back to Tesla's visionary work. His contributions to science and technology are more appreciated now than ever before, cementing his place as a true icon in the history of innovation. Tesla's influence extends beyond the realm of science and technology into popular culture. He is frequently referenced in movies, TV shows, and literature, often depicted as the quintessential mad scientist or the underappreciated genius. This cultural portrayal has helped to maintain his legacy and introduce new generations to his incredible contributions. In conclusion, Nikola Tesla's contributions to technology have left an indelible mark on the world. His pioneering work with alternating current AC motors revolutionized the way we transmit and use electricity, paving the way for the modern electrical grid. Tesla's ambitious experiments with wireless power transmission, although not fully realized in his time, laid the foundation for many of today's wireless technologies, including wireless charging and communications. Tesla's achievements extend beyond just AC motors and wireless technology. His inventive spirit led to breakthroughs in radio, robotics, and even the conceptual groundwork for technologies that continue to evolve. Tesla's enduring legacy is a testament to his visionary mind and relentless pursuit of innovation. He remains a pivotal figure in modern science, inspiring countless engineers, inventors, and thinkers to push the boundaries of what is possible. Reflecting on Tesla's genius, we see a man who is ahead of his time, whose ideas continue to influence and shape our technological landscape. His work serves as a reminder of the importance of imagination, creativity, and perseverance in the face of challenges. As we conclude this exploration of Nikola Tesla's life and work, we encourage you to delve deeper into the fascinating world of this extraordinary inventor. His story is a rich tapestry of innovation and discovery that continues to inspire and captivate. Thank you for joining us. If you enjoyed this video, please like, share, and subscribe for more educational content. Stay curious and keep exploring the wonders of science and technology.